Hello, everyone. We are back again to continue with our math journey, and I know you're excited. I hope you're doing well, by the way. I hope you're doing great. The goal of this class is to make math enjoyable and make math very easy. The last time we met, we looked at the different properties of sets. We looked at the commutative property. We also looked at associative property and then the distributive property. But I think today we want to focus on associative property and to see how to prove it. Now, the associative property says if you have, let's say, A union B union C, it's equivalent to A union B union C, like this. Now, let's start off by drawing a Venn diagram. Let's say that we have a Venn diagram that has, contains three circles: set A, set B, set C. So let's say we have set A, set B, set C. Now, let's be interested in A. If we take this one here, if we take set A, we're going to shade the entire region of set A. So let's use the yellow color to shade every part of set A, because that ring, this whole region is set A, regardless of if we're having B in there or C in there. But that's the whole region of set A. Now, the other thing that we can also look at is B union C. B union C. I want to change this color a little bit. I want to change this color. Be patient with me. I want to use a yellow color to do that, please. So we have that. It's A union, all right. That. Okay, so I've changed the colors. So we're now going to focus on B union C. Now remember, union is to bring the sets together. Union is to bring the sets together. So B union C means that a joining of B and C. And to do that, we're going to use blue, the blue color to do that. So we're going to color the whole of B. This is the region of B, right? If you can, I don't know whether you can see that, but this is the whole region of B and C. So C is also here down there, right? B union C. So shading everything in B and C means B union C. And then just shading the entire A is just a region of A. But remember, we need to draw another one to just indicate the entire framework. And if I say framework, what do I mean by that? Remember, we have B union C, which is the blue area, and then A, which is the yellow area. Now we want to join everything together. A union B union C. And what that means is that we are shading the entire region. So we have three circles like that. And then what we're going to do is to shade everything. So remember, we are joining the union of B. We are having B union C, which is what we did earlier, which is the entire area of B and C. So that's a union. That's B union C for you. The entire blue shaded area is B union C. But if we are joining A to A, then of course we are going to have this one also together. So it's the entire region. So A union B union C is the entire region being shaded together. Now let's look at the other side of things. Let's look at another Venn diagram with three circles like that. Now remember, the first thing to consider is A union B. Remember, set A, set B, set C. A union B. And to get A union B, we need to shade the entire region of A and B, which is this region right there. Now we need region C. And region C, this one, is this one here. That's the entire region of C. And we can safely say that if we want the union of A and B unionizing with C, it means the entire region. So the whole region, as you can see, that has been shaded is the whole of that, the whole region here. So you can see that this diagram is the same as that diagram right there. So we've been able to prove that the associative property is true. That if we take B union C and you unionize it with A, it is going to give is the same as A union B and unionizing it with C. I hope this helps. I hope this helps. The other part or the other thing, the other property within the associative property. So the associative property is true. This is the first one that we have looked at, but we're going to look at the second aspect of the associative property. So let me state that again. So the first part, we said that if you have A, sorry, if you have A union, the union of B and C, we said that it's the same as A union B with the union of C. And we've been able to prove that. Now, the second thing, or the second item under the associative property is, it says A, if you have A, intersection, the intersection of B and C, the intersection of B and C, it's equivalent to A intersection B and the intersection of C. So let's see how that comes out. Let's see how that one comes out. So let's draw our first Venn diagram right here with three sets: set A, set B, set C. So we have set A, B, and C. Now the first thing is to shade set A, and to shade set A, we have right here. This is set A. We've shaded that entire region, set A. Now, the next thing is to shade B intersection C. B intersection C. Now, the region for B intersection C is this region right here. This is where B and C intersect, because you can see that, as you can see, this is C. This is a set C right here. This is the set C. And then this is the set B. And you can tell that they intersect here. They meet at this point. So B intersection C is this region right here. And we also know that the set A is the entire region. The entire region right here. The entire region right here. The entire region right here. Okay? So now we want to find out how that is going to look like if we bring all the intersections together. If we bring all the intersections together, how is that going to look like if we bring them all together? So we have set A, set B, and set C. Now remember, we are interested in bringing the intersection of B and C, intersecting it with A. The key there is to intersect them together. So where do they meet? We know where B intersection C is. B intersection C is the region of red, the red region. And then the set A is the region of green. So if we want to find out where both of them meet, it is where we have both green and red. And where we have both green and red is basically here. Let me show you where that is. It's, I think, this region right here. Here. Right here. You can tell, right? It is that region here, over here. Okay, so now we're going to go to the next one just to find out if that is actually true. So we have three sets. You have set A, you have set B, and you have set C. So you have set A, set B, set C. Now we're going to first start off with A intersection B. A intersection B is this region. This region is A intersection B. This region right here is A intersection B. Why? Because you can look at it. This is the region of set A. This whole region is set A, and this whole region is set B. And where do they meet? They intersect right here. They intersect right here. They intersect right here. So that's the region of that's the region. This whole region is a intersection what? B, and we've shaded that portion in what? In blue. Now we're also going to take we're also going to shade C, the region C, and this is the entire region of C. If you look at it carefully, the entire region of C. Now we can. It is now clear. It is now clear where both of them meet. We can see that the three sets, set A, set B, set C, set A, set B, set C, we can see that they both meet in the region blue and red, which is this region right here. Because you can see here that is both blue and red. So that's the region right there. And we, as a result, we can see that these two Venn diagrams are equal because the here is the region that has been shaded, and that's the region that has been shaded. I hope this helps. We've been able to prove how the associative property works for both union and intersection. All right, I'll leave you here. We'll come again. But if you haven't subscribed to our channel, please do us a favor. I would like you to press the subscription button, like this video, and share it to as many people. Thank you very much. I'll come to you another time. Take care. Bye.